We are now starting our new topic. There's only 2 exercises on this, index laws. So the previous exercise on applying algebra, now you've got to do the chapter review for all the relevant questions, and you'll get a test on that, a separate test. But this one is called index laws. I'm going to give you a chance to copy down all these notes, and then I'll talk. Good job, everyone. Okay, so this exercise is about multiplying and dividing powers. So before we begin, index notation. When you've got a power, you might have seen these before, like squared. 5 squared is 25, or 5 cubed even. So when we've got that number there on the bottom is a base. In this case, it's A, it's a pronumeral. That's a base. We call this top number the power of. We call that the index or the power. Sometimes they call it the exponent. But I'm just going to refer to that mainly as the power. So this says a to the power of 5. Now that's in index form, this one there. And then when you write it in expanded form, it means a to the power of 5 does not mean 5 times a. It means a multiplied by itself 5 times. So it's a times a times a times a times a. That's an expanded form. Excellent. So there's 2 laws you're going to learn in this exercise. Index law 1. This is the rule. When you multiply terms with the same base, they must have the same base, you add the powers together. So what do I mean by that? Let's have a look. A to the power of 4, and we're multiplying it by a to the power of 3. Since they have the same base, the base is a, they're the same, they must be the same, you can just add those powers together. So 4 plus 3 is 7. So the answer is a to the power of 7. You're saying, well, why is that the case? I'll explain it to you. A to the power of 4 means a times a times a times a. A to the power of 3 means a times a times a. And if you're multiplying them together, all together you've got 7 a's multiplied together, and you can write it in index form, a to the power of 7. So that's in expanded form, and I've shown you why this rule, how that rule came about. So an example, you can have not just letters as a base, you can have numbers. So 5 squared times 5 squared. So remember, whoops. So what do you do, everyone? So when you're multiplying with the same base, you add the powers together. So it's 5 to the power of 4. And when it's a number like that, you can throw it into your calculator. Or you can use common sense. So 5 squared is 25. 25 times 5 is 125. 125 times 5 is 625. Sorry, that's to the power of 4, everyone, not squared. So change that in your notes. Good job. Alright, that is index law number 1. Now if you come up here, index law number 2 is the exact opposite. When you divide terms with the same base, you subtract the powers. So have a look here, everyone. A to the power of 5 divided by a to the power of 3. Again, it's the same base, so we can do this law. So it's 5 minus 3 is 2. Simple rule. And here's another one. A to the power of 5 divided by a to the power of 3. These two are the same. Divided by, and that means divided by. And I'll prove it to you. A times a times a times a times a. There's 5 of them on the top, and there's 3 of them on the bottom. So what can you do with fractions when you've got a common denominator? You can cancel. Cancel those, you're left with 1s. Cancel those, and cancel those. So you're left with 1 on the bottom line, and you're left with a squared on the top line. So really it's a squared over 1, which is just a squared. And that's how this law came about. Alrighty, let's do some questions now. So when you're multiplying with the same base, you add the powers. So they're all the same base. We've got 3 plus 7, which is 10. And what's this one here? There's nothing there, but it's really to the power of 1. So 10 plus 1 is 11. So it's 5 to the power of 11. And that's it. That's your answer. Next one. X to the power of 4 times x to the power of 3. Same base, you're multiplying, so you add the powers. So it's x to the power of 7. How easy is that? Now, next one is slightly harder. We have a normal number out the front this time. So the normal numbers, you just do normal multiplication. 4 times 3 is 12. That is not an index law, it's a primary school rule. 4 times 3 is 12. Now we've got an index law. a to the power of 2, or a squared, times a to the power of 7 is a to the power of 9. So we do them separately. 4 times 3 is 12, and then a to the power of 9. Excellent. And the last one, this time we've got a normal number, we've got x terms and y terms. So we do them all separately. 2 times 5 is 10. X to the power of 4 times x squared is x to the power of 6. Y cubed times y to the power of 8 is y to the power of 11. And we're done. Great job. Okay, let's go up here. Now we're doing some divisions. So remember, the rule is when you're dividing with the same base, you subtract the powers. So 8 minus 5 is 3. So you can just write 10 to the power of 3. Or another way to do it, you could have cancelled that. Cancelled the 5 of them with 5 from the top line, and you're left with 10 cubed on the top line, which is 10 cubed. If it asks for it in index form, there's your answer, 10 cubed. If it wants it as a normal number or a numeral, basic numeral, then you work it out. 10 times 10 times 10 is 1,000. But in this case, we'll just leave it as in index form. Alright, next one. You notice we've got a normal number out the front, so we cancel these just like we did in year 7. So common factor, 5 goes into both, 5 goes into 5 once, 5 goes into 15 3 times. So on the top line, we've got 3. And now, A20 over A5. You can either just cancel them, and you're left with A15 on the top line, or you can use the rule. 20 minus 5 is 15. So we're left with 3, and then A to the power of 15. And that's all on the top line, by the way. Awesome. Let's go to the next one. 10 and 4. 2 is a common factor, so I'm going to cancel that. That becomes 5. Divide that one by 2, and that one becomes 2. Awesome. So remember, you can just do the rule that we did. 6 minus 2 is 4, and that's going to be on the top line, x to the power of 4. Or you can cancel them. I'm cancelling the 2 from the bottom line with 2 from the top line. And if there's 2 gone from the 6, there's 4 left. So there's x to the power of 4 on the top. So now we just write down what we've got left. We've got 5, x to the power of 4 on the top line, and on the bottom line we're just left with 2. See, so I cancelled the x's, the common terms, or you can just use the rule that we just talked about. And the last one is a really hard one. I've done this one on purpose. 5 and 10. 5 is a common factor. That becomes 1, that becomes 2. So there's a 2 on the bottom line so far. I'm just going to cancel these rather than use the 10 minus 3 rule, which is 7, but cancel those 3 with those, and I'm left with a to the power of 7. Cancel 2 from the bottom line, 2 from the top line, I'm left with b to the power of 4. We've cancelled everything, now we just have a look. We've got a 1, so you don't need to write that. So we've got an a to the power of 7 and a b to the power of 4 on the top line. And on the bottom line, you've got a 2. So a lot of people, they cancel and they forget about that, but there's a 2 on the bottom line and there's no pronumerals. They've all been cancelled. So that's our answer there. Great job, everyone. If you can do 5J, 1 to 6, do all of them, please. It's a new concept. You've never done this before. So spend a bit of time and make sure you do it properly. Thanks, guys. See you next time.